All right, what's up, everyone? Welcome to week 95 of building my own operating system. And I'm going to pick it up where I left off last time. So last time we were working on these unit tests for my physmap address converter, which is a pretty simple module of code, but I'm trying to explore what it feels like to write unit tests for my kernel. And this is how I am doing that. Pretty happy with how things are looking. I was able to use this parameterized testing feature of Catch2 to make some pretty compact tests that just run it through a bunch of different kinds of inputs, where I kind of round trip a physical address to a virtual address and then back with two different bases, just to do a bit of checking. Excuse me. And there were a couple of things left that I wanted to do here. So let me see. So we had a couple, like the assertions could be better, and I think I want to try this actually. So let me see. So maybe just I want to try drawing things out a little bit. Also got this iPad here. Kind of skirt over to this empty zone. So can we see this? So basically here's the idea. Is let's say this is physical memory, or let's say this is the physical memory address space, and we actually, a small subsection of this is actually used for physical memory. And then let's say we have our virtual memory range over here, and let's say our physmap, our physmap is mapped right here. Maybe I'll try to make it a little more to scale. So basically, here's the physmap. And so basically, conceptually, physical memory gets mapped into this region, the physmap. And what we're just doing is the converter module is responsible for handling conversions between these two worlds, even though it's a quite simple conversion. It's just adding and subtracting. But there are some edge cases. So what happens if the physical address is outside versus inside the range? You could even, this is not really that practical, but you could imagine a weird physical memory where it doesn't start at 0. I don't actually know. I would need to think a little bit more about how realistic that, actually here it kind of doesn't. So maybe that is actually kind of interesting. So it actually is the case that we have a bit of this gap here. Before the start of physical memory. And so what happens over here then? That means well, in general, so the HHDM already has quite a few gaps. So there's physical memory, and then maybe I will try to correct this a little bit. So physical memory, and then for the most part, it's filled in the physmap, but there are going to be chunks missing. And these are going to correspond to oh wait, sorry, I can't see what I'm doing anymore. So there are going to be chunks missing, and those are chunks that correspond to these gaps That's the reserved and any bad memory segments that exist. And so in reality, it looks sort of like this. And so you are not allowed to just touch absolutely anywhere. Things are going to be mapped, but as a general idea, the physmap converter is not really trying to enforce the gaps. It's mostly concerned with this high-level idea of, is it within the physmap or is it outside the physmap? And so a case where you try to resolve a virtual address that is technically within the physmap but is not mapped would actually be a valid conversion, I think. I mean, it will fail if you try to access it because it's going to correspond to, well, it will be unmapped, and so actually that access is going to fail. But that, yeah, I can see that being kind of allowed. But what I'm trying to, what really is absolutely not sensical is doing a conversion outside this range. And that range is defined by the base, and then it's just whatever, pretty much just the end of the memory map, I'm guessing. Whatever, maybe I'll copy over a memory map so it's a bit closer. Yeah, so so here at the end of the memory map is like FD something something something, and that plus the length is going to dictate what we as the OS perceive to be the end of physical memory. So that is interesting. And so basically, yeah, just the idea is we are asserting that, let's say we get a V, the virtual address. V needs to be greater than or equal to the base, which is right here. And V needs to be less than, call it physmap end. These are, and that is going to check that it's within this region. And then what about the other case? And so it's, the physmap is also kind of relevant here. And so P, let's say P is going to be, it's going to need to be less than the memory map end, which corresponds to kind of this address at the very end of the memory map. So that's, and then also, but yeah, also what about before? Because technically, if we try, so technically in this region, it's sort of going to fall into like here or so, which is valid. So I just got a bit distracted trying to think if I could actually share. I'm like zooming in on stuff on my iPad, but you can't really see the zooms and stuff. So I was just distracted thinking if I could somehow share my iPad screen, but I'm not sure I really can. Okay. Question is, what happens if you try to, for example, resolve a p address of 0? Things that are just not even in the memory map. So that would theoretically correspond to a range here, but it's just not going to be mapped. And so the question is, what's the initial assert? Do we want to assert that, I mean, p is equal than 0 is not really a sensible assertion because it's a uint 64t anyway, or do we want to do something like p is greater than or equal to mem map begin, which would be 1000. I don't know if there is a harm in really doing this assertion, so I'm sort of inclined to add it. But what I'm realizing as I think about this more is there are maybe some edge cases. What about trying to resolve vert adders in holes in the memory map? It's not, I mean, that should never really happen. It's not mapped yet because it's reserved or bad memory, but it's within the physmap. I don't really want to be doing really sophisticated assertions though, to be honest. I mean, to sort of check if it's in a hole would require a bit more of an in-depth, I don't know, you need to see if it's within the memory map. And that's a little bit more heavyweight than I would like to do in an assertion and these kind of critical functions that are supposed to be just very small. So I think I'm just going to say no, let's not bother. So I'm just going to try to capture that. Should we assert that it's not in a mem map hole? I don't know, but let's not. It's expensive. Also, this is like, I don't know, kind of a more theoretical edge cases. So even as a starting point, what do I need to do? So first I'm going to test. I'm just going to add a temp commit for some tests and stuff like this. So even as a starting point here, the physmap address converter is going to need to kind of have a memory map to work with. And yeah, there are different options for us to do this. The most straightforward option is to have it probably take a reference to the span. So currently vmine owns that memory, and so we're using the L memory map span to refer to it. And that's sort of what I'm passing around to the bitmap frame allocator, and I could also pass that into the physmap adder converter. I'm thinking it would be nice to have some convenience methods, for example, for returning the end. And since it's it's a span, so I don't really have those, and so I would need to make something new for that. I can just prototype it here. Memory map. Span wrapper. I don't know. And it's going to take memory map span. And it's going to offer things like 64T start and end, I suppose, is mostly what I'm thinking of here. And going to assert that map size because we need at least one entry, and then we're going to return memmap I thought I forgot how to use spans. Base. Right, there we go. And kind of a similar thing here. It's going to be oh wait, no, can I do better than this? I'm indexing into 0, but like maybe there's like begin and end that I'm forgetting about. Right, begin, yeah, wait, front and back, that's what I'm talking about. Dot front base. Dot back base plus map dot back length. Right. Something like that. And then I could even have my own unit tests for this thing. Maybe I'll do that. I don't know. But the reason I sort of hesitated is because it's possible that in the future we might get rid of the span thing entirely, because we might just copy in the requests into the kernel's memory rather than leaving them in the bootloader's memory. And that sort of is going to make a lot of this stuff obsolete, because then we just no longer need a span type and a span wrapper. We're just going to have a type that actually owns the request data, and it can have these methods. Kind of getting lost. But it's not necessarily a hole I want to dive in right this moment, or could I? I mean, I could. I could think about it, at least. I could. So what would it look like? So we would have our own just memory map, like memory map class, and it would actually own the entries, and so we would we might have like a vector or something of entries, and store them, yeah, just store them into this vector actually. But I feel like it's a little bit of a distraction right now, so even if it does involve a bit of rework later, don't use L memory map span, use L memory map, which actually owns the data, for example. Then things can just take a reference to the L memory map. Okay, yeah, so for the moment, I'm not going to do this. Just going to go here, and then maybe I'll just add, I mean, it's not lovely to just do this all in the same unit test file. I could technically, now here's the thing. Now I need that mock, I need the mock memory map to actually be in its own file. I'm gonna call this mock. I'm gonna call this mock L memory map, or maybe L mock memory map. The L stands for Lima or Limini, and we're going to include just these things. And then I also need limit util. So, okay, good. So now this thing is going to include L mock memory map. This stuff goes away. Technically, these things get renamed to, I'm calling it L, but maybe I just don't do that for the moment. Don't know why this error is there. Let me, oops, what breaks? Okay, so the only thing that's breaking is snap battery converter. I'm going to just comment this out for the moment. Okay, so these are, okay, good. So these are there, and then now this thing is not compiling because it doesn't know about the span, which is here. So now this should compile, and now I can go to my tests. And now I can do some random tests. And so now we can, yeah. Empty map. So now we can have the empty thing, wrapper, span, and check throws wrap.start and end, right? Let's try this out. Okay, what? Wait. So I'm having a problem because I'm trying to hold a reference here, but that's a little bit odd because I sort of thought the bitmap allocator did the exact. Wait, it holds. No, wait, what? Oh, wait, no, span doesn't. The span doesn't need to be referenced because that's cheap. So it can be held by value. That's That's the deal. It's actually, wait a sec. No, span is not even contained. It's not even stored in the bitmap allocator. That's only used like kind of on a temporary basis for constructions. That's the difference. And so actually here, the problem is trying to store a reference to the temporary span. But now I'm just storing it by value, and it's seg fault. Oh wait, because I said equal, it needs to be greater than 0. Or wait, greater than 0. Or no, better is not empty. There we go. So now, okay, this thing throws, that's good. So now, now what? We're going to test single region, and single region will have this. And so we're going to check that start equals hex 2000, end equals hex 3000, if I'm getting that right. Let's try that. Seems to work. Let's break it. Seems to fail. Good. Two regions. So now let's just give it another region. Call it 5. And so start's going to be 2, end is going to be hex, I don't know, 4. 9,000. And that's enough for me. So, so that's like a little bit of this wrapper thing. So now we can, so the span wrapper is going to be cheap. Call it fmap. And now we can start to do some asserts here. So now, all right, so yeah, let's just start. So the assert is something like, I mean, these could even be physical addresses, right? That's what we're really returning here, right? Physical addresses. And so could I do something like p-adder is greater than or equal to map.start and less than map.end. Okay. Cool. An assertion failed because in the tests now, I am not passing a memory map at all. Interesting. So that didn't produce a compile error because I don't have a constructor. And this thing default initialized to an empty span. But that's like, at least that's kind of cool that actually yes, this assertion that I added over here caught things. That's kind of neat. So I guess what I will do about that is I will add a constructor, or maybe I'll ask AI. Setor. that requires passing both. Okay, nice. So now that we have a constructor, we can, yeah, we're not going to get the assertion, we're going to get a compile error. And now in order to get rid of that compile error, I need to pass one of these things. And I just need to touch up a few places. I could even just take a normal memory map. Oh, okay, no, I need the span. Wait a sec though. This is kind of weird actually. This is, I think it actually did it slightly wrong, I guess. It takes the span and then, then it constructs the wrapper using the span. Wait, maybe that's right. Actually, no, that is right. So I have this helper, returns the span, and that's what I want to take in here. I just convert it to the wrapper internally. Like I said, probably a lot of that will change in the future. So now tests should compile again. And now an assertion is failing. On 58. Interesting. Wait a sec. So now, yeah, so now these addresses need to be valid for the memory map actually. And currently the memory map does not say that they're valid. And so I need to fix that. So let's call it 52. Let's just do it. I'm just going to do it like it says here. And then all right, we're going to have just 3 usable chunks. Okay, 6. What I would like to see is which one is failing? Oops. How do I get verbose output? I currently do not know. p-adder is greater than memmap start. So obviously, 0, that would be the one. Yeah, oh, there we go. Oops. Okay, there we go. So now, good. So now we have a val, and really, I mean, this thing is only needed for here, so maybe we can make this a bit tighter. Oh wait, but no, this was needed there too. So And in this case, it doesn't really matter, actually. So maybe I can just make the mock, this one empty. Good, okay, cool. Okay, so that's a bunch of changes. But I would call that progress. And so now, okay, we have a couple of these assertions. And then, okay, now it's up over here. And so we want to assert that the given v-adder, coming back over here, we want to assert that the given v-adder, so we're already able to check this thing, assert that it's greater than or equal to the base, right? So this whole region not allowed, but this region, and then now we need this one for over here. So v-adder is less than, and then what is it going to be? It's going to be I'm just kind of laughing because we could even call this function, we could call phys to vert on the, wait a sec. I mean, the stupidest thing to do is just take the base plus the end of the memory map. And I'm wondering if that will actually assert because we cannot, because the end of the memory map is not, because it's the one past the end, so that's actually not a valid number to push through the conversion. And so it would, I mean, physmap base plus memmap dot end. And maybe I'll take a moment to fix this up. Just run the test and see what happens. They pass. Just out of curiosity, let me just try that idea I had, which is not going to work. So the idea, I mean, the idea was this, but this is going to assert, I believe. Also, is there a, there's a compile, or the, wait, no. It's going to assert, I think. Yes. Yep, it asserted. It's a kind of unfortunate we can't get much more information. Surely there is some way to do this. But yeah, it's hitting this assertion right here almost certainly because, I mean, I could and what happens if it exits? Yeah. Yeah, I mean, yeah, there's different ways I could go about trying to get a stack trace to actually learn more about that, but it's just quite clear, and that I'm trying to run the end through this conversion, which is not a valid operation. And so I just need to do the simple thing and just manually do my own addition. So now I can start to do some of these checks though. So And that is going to require actually adding an entry here. And so maybe I will add a very simple entry right here. Oops. And okay, we're gonna start with these physical address conversion checks. We're gonna check throws that this fails. Also 5.1 FFF fails, right? Because that's the last one before. So let's just verify this. And just to see the test fail, let's just, so this thing should not throw. Okay, good. And the test failed because it didn't throw. So now these things both threw, and now we're checking kind of the other side, or then we need to check kind of like the other end. And so now it's going to be kind of like 53. So this whole range, right, I mean, I'll just add this for good measure. These things should just work, and then as soon as we get out of range, this should throw again. Right. Cool. Okay, so now we're over here. Just phys adder conversion checks. And then now we're over here kind of on the other world, and we're just doing a very similar thing. And we're checking, okay, we're checking kind of some random low number. And then what I want to do is just take this number, and test that this also fails. And then phys, but no, that's not what I wanted. Then this should succeed. This should succeed, except I need best way to convert to cast this to void star. Yeah, it also think it's a little bit chunky, but okay. And then kind of a similar deal, but except wait a sec. So this, no, that was wrong. So this is going to be valid. The page is only, it's only one page long, so this is valid. And then we're going to be invalid again as soon as we get to here, right? So let's kind of just run that. No exception was thrown where one was expected. Oh wait, no, wait a second. I'm kind of going crazy. So, what is going on? So here's the memory map, is this 52,000 chunk. And therefore, okay, I mean this, it's kind of funny that we're a little bit asymmetrical here. So here we're checking that it must be greater than or equal to the memory map start. Here we're just checking that it's past the physmap base. But is that wrong? Should we actually say you're not allowed to run conversions before that, actually. Maybe this is better, actually. So this is sort of this is more consistent, I guess. And so here we're talking about this kind of gap thing. So in this test, we're banning access to try to do conversions here. And likewise, maybe we need to ban these any conversions that try to happen in kind of like this, the small gap here that corresponds to the gap here. And so that's what, so now that's what this does. And I guess that probably makes sense to stay consistent. So actually now, so this thing is going to fail. So this thing is going to be a check throws now. Yeah. And this is also not going to work. What is going to work is 52,000. And so what is not going to work is 51 FFF. That's still not there yet. 52 is going to be the first one that works. This is going to be the last one that works. And then 53 is going to be the first one that fails. And these are passing. Just to verify, what can I try to verify here? I can try to just run an invalid conversion. Yep, that fails. Okay. Vert conversion asserts. Phys asserts. Okay, cool. So now, now that's kind of coming together. We are in a pretty good place. The kernel wasn't compiling because I didn't fix that construction. Nice, so we're building and our tests are running. Just curious to learn catch 2, how to verbose test output -s. That did not work. I guess I need to, So here's our verbose output of all the tests that are running and passing. And it includes all of these conversion ones. So temp whip phys converter tests. Nice. So now we got a bit of test coverage for our physmap adder converter. And you know what it is? For something so simple as just like adding numbers and subtracting numbers, it is slightly more involved than I thought, because it's kind of nice to have these assertions in there, which makes you think about some edge cases that happen with it, like what happens if you try to convert things that are before and after the end. So That is looking pretty good to me. I think I'm going to end the stream here. And then next time we're going to keep it moving, maybe getting into the paging stuff, finish up this cast stuff. So yeah, I'm going to call it here. Thanks a lot for watching. And if you like this kind of content, I would appreciate it if you subscribe to my channel. That would be great. And I will see you in the next video next week. All right, cheers, bye.